The date is January 27, 1967. The location is a buried concrete bunker deep within the frozen forests of the Kola Peninsula, the northernmost tip of the Soviet Union. Outside, the wind howls across the tundra at 30 degrees below zero, but inside the command center of the PVO Strany, the Soviet Air Defense Forces, the air is stagnant, smelling of stale tobacco smoke, ozone, and nervous sweat. Senior Lieutenant Viktor Korolyov sits hunched over the P-14 Tall King early warning radar scope. His job is monotony defined. For months he has watched the rhythmic, sweeping green line paint the same empty airspace. Occasionally, a commercial airliner drifts by, or a flock of migratory birds creates a fleeting flurry of static. But today, the rhythm breaks. At 0900 hours, a contact appears on the far edge of the scope. It is faint at first, ghosting in and out of the clutter near the Norwegian border. Victor adjusts the gain, narrowing his eyes. The blip solidifies. It is not drifting like a weather balloon. It is not cruising like a bomber. It is slicing through the grid lines with a velocity that makes Victor tap the glass of his monitor, certain the equipment has malfunctioned. He grabs his headset. Target acquired. Sector 4 to 7. Altitude, undetermined. Speed. He pauses. He checks the calculation again. Speed is Mach 3. Repeat. Target velocity is Mach 3. The room goes silent. In 1967, Mach 3 is not a speed for aircraft. It is a speed for missiles. It is a speed for things that explode, not things that fly. The commander rushes to the station, leaning over Victor's shoulder. Is it a missile launch? Are the Americans firing? Negative, Comrade Colonel, Victor replies, his voice trembling slightly. It is not on a ballistic trajectory. It is maneuvering. It is maintaining altitude. It is turning. This is the moment the impossible happens. The laws of physics, as understood by the Soviet engineering elite, dictate that any object moving through the atmosphere at 3 times the speed of sound generates friction, heat intense enough to melt aluminum. To sustain that speed, an engine must consume fuel at a rate that would drain a standard fighter jet in minutes. It is a sprint, a desperate dash. But this ghost on the radar is not sprinting, it is cruising. For the next 40 minutes, the men in the bunker watch in paralyzed confusion as the target traces a lazy, arrogant loop along the edge of Soviet airspace. It does not slow down, it does not descend to cool off. It stays up there, pinned at 80,000 feet, a height where the air is so thin it is practically a vacuum, moving faster than a rifle bullet. Before we unravel the mystery of this terrifying machine, if you want to uncover more hidden histories of the global superpower standoff, make sure you subscribe to Cold War Impact. We dig into the declassified files to bring you the stories they didn't want you to know. Back in the bunker, the confusion is turning into dread. The colonel orders an intercept. 2 MiG-21 aircraft are scrambled from a nearby airfield. They are light, fast, and flown by the best pilots in the regiment, but the intercept is a farce. As the MiG-21 aircraft climb, straining their engines to reach their service ceiling of 60,000 feet, the target simply exists above them, untouchable. The Soviet pilots look up through their canopies into the dark purple sky. They report seeing a silver streak, a glint of sunlight far above, moving with a serenity that is insulting. They push their throttles to the stops, dumping fuel into their afterburners to try and close the gap. But as they push their machines to the limit, their engines begin to overheat. Warning lights flash in the Soviet cockpits. They are forced to break off, diving back into the thick air to save their jets from disintegrating. The target does not react. It does not evade. It simply continues its patrol, burning a line across the sky. This was not just an intrusion, it was a technological paradox. To the engineers in Moscow who would later analyze the radar tapes, the data made no sense. Jet engines work by sucking in air, compressing it, mixing it with fuel, and igniting it. At Mach 3, the air entering an engine is moving so fast and with such pressure that it creates a shockwave capable of choking the engine, causing a flameout. It is like trying to drink from a fire hose while sprinting. Furthermore, the heat generated at the inlet should be melting the turbine blades. Yet, this machine was not only surviving, it seemed to be thriving. The radar operators noted something even more baffling. As the object accelerated, its heat signature didn't create the chaotic bloom of an engine struggling against drag. Instead, the signature stabilized. The faster it went, the more efficient it seemed to become. This flew in the face of everything Soviet aerospace design understood. Their own high-speed interceptors, like the heavy Ye-152 prototypes, were brutes. They achieved speed through raw thrust, fighting the air, vibrating violently, guzzling fuel, and destroying their own engines after a few minutes of supersonic flight. This American ghost was dancing with the shockwaves. By the time the blip finally turned north and vanished off the scope towards the Arctic Ocean, the mood in the Kola bunker was not one of anger, but of profound insecurity. The Soviet Union had spent billions of rubles building a wall of surface-to-air missiles and interceptors designed to stop American bombers. They had built a fortress around the motherland. But that morning, they realized their fortress had no roof. The report Victor typed up that evening was sent via secure courier directly to the Kremlin. It did not contain bluster or propaganda. It contained a terrified question that would haunt the Soviet military-industrial complex for the next 2 decades. How are they doing this? The search for that answer would lead the KGB and Soviet engineers down a rabbit hole of paranoia, forcing them to question the fundamental limits of metallurgy and thermodynamics. They assumed the Americans had discovered a new element, a new fuel, or perhaps a new form of propulsion entirely. They could not imagine that the answer lay in a mechanical trick so ingenious, yet so counterintuitive, that it turned the enemy, the air itself, into an ally. But on that frozen morning in 1967, all they knew was that something was up there, looking down on them, and they were powerless to stop it. The impossible machine had arrived, and the great Soviet panic had begun. The radar tapes from the Kola Peninsula did not stay in the frozen north. Within 48 hours, they were in a leather briefcase, handcuffed to the wrist of a courier, traveling by train to Moscow. They ended up on a heavy oak table in the Central Aerohydrodynamic Institute, known as TSAGI. This was the brain trust of Soviet aviation, the place where the laws of aerodynamics were written and rewritten by the finest minds in the communist world. But looking at the flight data of this American intruder, those minds were blank. A committee was formed immediately. It included lead propulsion engineers, aerodynamicists, and intelligence officers from the GRU. The atmosphere in the room was not one of scientific curiosity, it was one of defensive panic. The data presented a terrifying picture. The target was maintaining Mach 3.2 over 3,500 kilometers per hour for sustained periods. This duration was the anomaly that kept the engineers awake at night. To understand their confusion, you have to understand the state of jet propulsion in the late 1960s. The Soviets were masters of brute force. They knew how to make things go fast. They had built the MiG-21 aircraft and were testing the terrifying MiG-25 prototypes, but they knew the cost of that speed. In a standard turbojet engine, air is sucked in the front, compressed by spinning blades, mixed with kerosene, and ignited. This explosion shoots out the back, pushing the plane forward. But at Mach 3, the air ramming into the front of the engine is not a breeze. It is a solid wall of pressure. This compression heats the air instantly. Before the air even touches the engine's internal compressor, it is already over 400 degrees Celsius. When you try to compress air that is already that hot, the metal blades of the turbine soften. They stretch. Eventually, they melt or shatter, turning the engine into a grenade of shrapnel. The Soviet engineers looked at the American flight path. The intruder had flown at Mach 3 for over an hour. It is impossible, one senior engineer argued during a heated session in 1968. If they are using standard turbojets, the turbine inlet temperature would exceed the melting point of the alloys. The engine should have liquefied 10 minutes into the flight. The investigation splintered into different theories, each more desperate than the last. The first theory was that the Americans had developed a nuclear-powered aircraft. This had been a fear since the 1950s. A nuclear reactor wouldn't need to burn fuel in the traditional sense. It could heat the air indefinitely. This would explain the unlimited range and the high speed. But radiation detectors on Soviet border patrols had picked up nothing. No trail of isotopes, no glowing exhaust. The theory was discarded, but the fear remained. The second theory was that the aircraft was actually a rocket glider, similar to the experimental X-15. Perhaps it was dropped from a massive bomber, lit a rocket motor to dash across the border, and then glided back. But the radar tracking contradicted this. The object didn't glide, it accelerated out of turns. It climbed while at speed. A glider loses energy. This machine was generating it at will. The investigation moved from the chalkboard to the cockpit. The Soviet Air Force was ordered to visually identify the target at any cost. They needed to see the engines. They needed to know if there were scorch marks, strange intakes, or rocket nozzles. This order led to some of the most frustrating intercepts in aviation history. Soviet pilots flying the new MiG-25 aircraft, the Foxbat, were the only ones with even a prayer of catching it. The Foxbat was a masterpiece of brute force engineering, built specifically to counter this threat. It was two massive engines with a cockpit strapped to them. It could hit Mach 2.8, maybe Mach 3, if the pilot was willing to wreck the plane. But the pilots reported a demoralizing reality. To reach the intruder's altitude, the MiG-25 aircraft had to accelerate to their absolute limit. The pilots would describe the thermal wall, the moment when the friction heat became so intense, the canopy glass felt hot to the touch, even through their gloves. They would look at their fuel gauges and watch the needle drop visibly, like the second hand on a clock. One report from a pilot stationed in East Germany described the encounter vividly. He had been vectored to intercept a high-speed target over the Baltic Sea. He pushed his MiG-25 to Mach 2.8. His engines were screaming, the afterburners dumping raw fuel into the exhaust to sustain the speed. His warning lights were flickering, engine overheat, hydraulic pressure critical. He looked up. 10,000 feet above him, he saw the Blackbird. It wasn't struggling, it wasn't vibrating. It was a dark, sleek wedge, moving with an eerie smoothness. The pilot reported that the American plane didn't even seem to have afterburners lit in the traditional sense. There was no massive plume of fire, just a distortion of air behind it, like a mirage on a hot road. As the Soviet pilot reached the edge of his flight envelope, his engines beginning to surge and choke on the supersonic air, the American pilot simply nudged his throttle forward. The Blackbird accelerated away, leaving the Soviet jet choking in its wake. The Soviet pilot had to abort, gliding back to base with engines that were practically scrap metal, cooked by just a few minutes of high-speed chase. This failure deepened the mystery back in Moscow. The MiG-25 engines, the Tumansky R-15 seconds, were some of the most powerful ever built, yet they suffocated at those speeds. The air pressure was too high, the drag was too great. How was the American engine swallowing that supersonic air without choking? The Soviet intelligence apparatus began to suspect a trick. They analyzed the contrails, they stole snippets of technical manuals from third-party contractors. They realized the American plane, which they now identified as the SR-71, was using a special fuel called JP-7, but the fuel alone didn't explain the physics. The engineers at Sagi began to suspect the Americans were using a cycle they couldn't replicate. Was it a ramjet? A ramjet has no moving parts and works better the faster it goes, but a ramjet cannot work at low speeds. You cannot take off with a ramjet. You need a turbojet to get off the ground. So, was it two engines? Did the pilot switch from a jet to a ramjet mid-air? The spy photos showed only two exhaust nozzles, not four. The conclusion they reached was terrifying in its implication. The Americans had built a hybrid, a transformer, a machine that was a normal jet on the ground but metamorphosed into something else in the sky. But admitting this was one thing. Understanding how to build it was another. The Soviet materials science lag was a major hurdle. They struggled to manufacture titanium of high enough purity to withstand the heat, let alone create the complex, moving geometry required for such an engine. As the 1970s began, the Blackbird became a legend in the Soviet ranks. It was the ghost that couldn't be caught. Radar operators would simply log the track and watch it go, knowing there was nothing they could do. The investigation had failed to produce a counter-weapon. They had built the MiG-25 to kill it, but the MiG-25 was a sprinter trying to catch a marathon runner. They knew what it was doing. It was flying faster and higher than anything on Earth. But the secret of the J-58 engine remained a black box. They didn't know that the answer wasn't just in the engine itself, but in the plumbing around it. They didn't realize that the Americans had decided to stop fighting the wind and instead had invited the storm inside the engine. While the Soviet engineers in Moscow were chasing ghosts and debating the laws of thermodynamics, the answer to their riddle was sitting under a hot sun in Burbank, California. It was hidden behind a chain-link fence at the Lockheed Advanced Development Projects Division, better known to the world as the Skunk Works. Here, the air smelled of jet fuel and epoxy, not fear. The man running the show was Kelly Johnson, a genius with a reputation for doing the impossible. Johnson and his team had realized early on what the Soviets were just beginning to suspect. Standard jet engines were useless for the mission. They needed to fly at Mach 3.2 to outrun missiles. But as we established, at that speed, the air entering the engine is hot enough to melt the turbine blades. The American solution was not to build a stronger engine that could fight the heat. Their solution was to build an engine that changed its own anatomy mid-flight. They selected the Pratt & Whitney J58 engine. On a test stand, sitting still, the J58 was a powerful but fairly standard turbojet. It screamed, it burned fuel, and it generated thrust. But the magic wasn't in the engine itself. It was in the massive structure built in front of the engine. If you look closely at the SR-71 aircraft, you will see two giant, sharp cones protruding from the engine inlets. These are not just for aerodynamics, they are the secret weapon. These cones, or spikes, were movable. They were controlled by a complex analog computer, a mechanical brain of gears and cams that could slide the spike forward and backward up to 26 inches. Here is the genius that baffled the Soviets. When the Blackbird was sitting on the runway or flying at subsonic speeds, the spike was locked forward. The air flowed in smoothly, the compressor spun, and the engine worked like a normal jet. It sucked, squeezed, banged, and blew. But as the pilot pushed the throttle forward and the plane crossed Mach 1, then Mach 2, the computer woke up. It began to retract the spike deeper into the engine throat. At Mach 3, the air hitting the front of the plane is a violent, supersonic shockwave. The retracted spike was positioned perfectly to capture this shockwave and trap it inside the inlet. Instead of letting that shockwave destroy the engine, the shape of the inlet slowed the air down from Mach 3 to subsonic speeds in a fraction of a second. This massive reduction in speed converted the kinetic energy of the air into pressure. Immense pressure. The air wasn't just entering the engine, it was being rammed into it with the force of a hydraulic press. And then came the second trick, the one the Soviet pilots couldn't see. Inside the engine housing, Johnson and the Pratt & Whitney engineers installed a series of bypass tubes. These were essentially trapdoors. When the pressure became too high and the air too hot for the delicate turbine blades to handle, the engine opened these doors. The massive rush of super-compressed air didn't go through the core of the engine, it went around it. It bypassed the compressor, the burner cans, and the turbine entirely. It was piped directly into the afterburner at the rear of the plane. At that moment, the J58 ceased to be a turbojet. It became a ramjet. In a ramjet, you don't need a compressor because the speed of the aircraft compresses the air for you. The engine core, the complex, spinning machinery was reduced to a simple pump, just keeping the flame lit. The real thrust was coming from that bypassed air, mixed with fuel and ignited in the massive tailpipe. This explains the impossible phenomenon the Soviet radar operators saw. In a normal jet, the faster you go, the harder the engine has to work to suck in air, and the more fuel it burns to keep spinning. But in the SR-71 aircraft, the faster it flew, the harder the air rammed itself into the engine. The engine actually had to do less work at Mach 3 than it did at Mach 1. The efficiency went up. At Mach 3.2, the inlet design that spike and the bypass doors was generating 80% of the total thrust. The engines were essentially coasting, being pushed along by the sheer force of the air they were swallowing. This was the cycle the Soviets couldn't replicate. The Americans had turned the enemy the crushing air pressure into the propulsion source. To fuel this beast, they couldn't use normal kerosene, which would boil and explode in the tanks at those temperatures. They developed JP7, a fuel so stable you could drop a lit match into a bucket of it, and it wouldn't ignite. To light it, they had to inject a chemical called triethylborane, or TEB, which exploded on contact with air, creating that signature green flash you see in footage of the Blackbird starting up. While the Soviets were trying to build engines with brute strength, the Americans had built a musical instrument. It required precise tuning. If the spike was off by a fraction of an inch, the shockwave would be unstarted, spat out of the front of the engine, causing the plane to violently yaw and potentially break apart. But when it worked, and it did work, it was untouchable. The pilots in the SR-71 suits, cruising at 85,000 feet, were flying the only machine in history that got better, stronger, and more efficient the closer it got to the limits of physics. They were flying a miracle of engineering that turned the atmosphere into fuel. And down below, the Soviet pursuit was about to hit a brick wall. The turning point came not in a laboratory, but in the terrified report of a Soviet pilot pushing the pride of the USSR to its breaking point. It is 1972. The location is the airspace over the Sinai Peninsula. The Soviet Union has deployed its secret weapon, the MiG-25 Foxbat, to Egypt to counter Israeli Phantom jets. But their real target is the high-flying American reconnaissance flights. A Soviet pilot, call sign 831, is vectored to intercept a target moving north at Mach 3.2. This is the confrontation the Kremlin has been waiting for. The MiG-25 is fully fueled, armed, and stripped for speed. The pilot engages his afterburners. The massive Tumansky engines roar, dumping gallons of fuel per second. The MiG-25 accelerates through the sound barrier, past Mach 2. The acceleration is violent. The aircraft shudders as it punches through the dense lower atmosphere. At 40,000 feet, the pilot is doing Mach 2.5. He looks at his instruments. The engine temperature gauges are climbing into the red zone. The overheat warning lights flicker on. He has strict orders. Do not exceed Mach 2.8 for more than 3 minutes. If he goes faster, the engines will suck in their own compressor blades. But the target is still above him, and crucially, it is pulling away. The pilot makes a desperate decision. He overrides the safety limiters. He pushes the throttle past the detent, dumping raw fuel into the tailpipe. The MiG-25 hits Mach 3.2. The plane is screaming. The paint on the nose cone begins to blister from the friction heat. The cockpit glass radiates heat like an open oven door. And then, he sees it. Through the haze of the high altitude, he spots the SR-71. It is not vibrating. It is not struggling. It looks like a silver dart, suspended in motionless oil. And then the Soviet pilot witnesses the impossible. He sees the exhaust plumes of the American plane change. They tighten. They turn into a series of perfect, glowing diamonds, shock diamonds, trailing behind the engines. The SR-71 does not bank away or dive. It simply accelerates. It walks away from the MiG-25. The Soviet pilot watches, helpless, as the American plane vanishes into the curvature of the earth. His own engines begin to surge violently. Bang, bang, bang compressor, stalls that sound like cannon fire. He chops the throttle and dives, praying his aircraft doesn't disintegrate. When he lands back in Egypt, the ground crew is horrified. The engines of the MiG-25 are destroyed. The turbines are fused together. The heat was so intense it warped the steel fuselage. The aircraft is a wreck. It flew at Mach 3 for 5 minutes, and it effectively killed itself to do it. The report of this incident made its way to the desk of the chief designer at the Mikoyan Gurevich Bureau in Moscow. And this is where the shock finally hit home. Intelligence reports had finally pieced together the mechanism of the J-58 engine. They laid the schematics of the American engine next to the wreckage of their own MiG-25 engines. The realization was a gut punch to the Soviet ego. They are not fighting the pressure, a senior analyst reportedly said, staring at the diagrams of the bypass tubes. They are surfing on it. The Soviets realized that while their pilots were risking their lives to push a wall of air out of the way, the Americans had built a machine that swallowed the wall. They understood now that the SR-71's engine efficiency increased with speed. At Mach 3, the SR-71 was burning less fuel per mile than it did at Mach 2. It was in its natural habitat. The MiG-25, by comparison, was drowning. But the reveal got worse. To build a plane that could survive that continuous heat, 500 degrees on the skin, 1,000 degrees in the exhaust, you cannot use aluminum. Aluminum turns to soft putty at those speeds. You need titanium. The Soviet Union sat on the world's largest reserves of titanium ore. It was a strategic metal, strictly controlled. They assumed the Americans, who had very little titanium, would be forced to use heavy steel, like the MiG-25, or give up. Then came the final, humiliating piece of the puzzle. The KGB discovered a network of shell companies, dummy corporations set up in third world countries, supposedly buying titanium for pizza ovens and bicycle frames. The prompt trail led back to the CIA. The silence in the Kremlin meeting rooms was deafening. The Soviet Union had sold the United States the very metal used to build the spy plane that was now humiliating them. They had mined the ore, refined it, and shipped it to the enemy, who used it to build a fuselage capable of withstanding the heat that melted the MiG-25. The impossible engine was housed in a stolen body. The futility of the Soviet response was now clear. They had built the MiG-25 Foxbat as a counter. It was a terrifying machine in its own right, fast, armed with massive missiles, and rugged. But it was a point defense interceptor. It could sprint to the corner of the block, bark, and come back. The SR-71 was a marathon runner that could sprint the whole race. The Soviets tried to upgrade their missiles. The S-200 system was designed with a massive warhead specifically to reach the Blackbird. They developed the MiG-31 aircraft, a much more sophisticated interceptor with a phased array radar and data links designed to hunt in packs. But the physics remained the ultimate barrier. Even with the MiG-31, the intercept window was seconds long. If the calculation was off by a degree, the missile would miss. If the SR-71 pilot simply turned slightly, the missile, traveling at Mach 5, couldn't turn tight enough in the thin air to track it. The revelation was absolute. The Americans hadn't just built a faster plane, they had mastered a flight regime that the Soviets could visit, but could not live in. The J-58 engine wasn't just propulsion, it was a thermal management system that used the violent energy of the atmosphere to feed itself. The Soviets were left with a warehouse full of wrecked MiG-25 engines and a sky full of ghosts they could see, track, and hate, but could never touch. The final scorecard of the Cold War skies can be summarized in two numbers: 4,000 and 0. Over the course of its service life, spanning 3 decades, over 4,000 missiles were fired at the SR-71 Blackbird. They were fired from North Vietnam, from North Korea, from Libya, and from the borders of the Soviet Union. Every single one of them failed. The Blackbird, the plane that broke the rules of thermodynamics, was never touched by enemy fire. This statistic is not just a testament to a pilot's skill, it is the mathematical proof of an engineering checkmate. By the late 1980s, the Soviet Union had effectively bankrupted itself trying to build a roof over its empire. They had constructed thousands of S-200 and S-300 missile sites. They had produced over 1,000 MiG-25 interceptors and over 500 of the advanced MiG-31 aircraft. They had trained entire generations of radar operators to look for the fast mover. The economic disparity was staggering. The United States had built only 32 SR-71 aircraft, a tiny fleet, yet this handful of black jets forced the Soviet Union to spend tens of billions of rubles on a defense network that, practically speaking, did not work against the primary target. This brings us to the true legacy of the mystery. The J-58 engine wasn't just a propulsion system, it was a symbol of the widening gap between two distinct ideologies of innovation. The Soviet approach was logical, robust, and industrial. They looked at the problem, we need to go fast, and they applied more power. They built bigger engines, steel frames, and stronger rockets. It was a philosophy of brute force. It produced the MiG-25, a magnificent machine in its own right, but one that was fundamentally limited by the materials it was made of. It was a sprint runner trying to keep up with a bullet. The American approach, epitomized by Kelly Johnson and the Skunk Works, was different. It was experimental, expensive, and seemingly reckless. They looked at the problem and decided to change the physics of the environment. They realized that fighting the atmosphere was a losing battle, so they redesigned the engine to feed on the violence of the speed. They built a plane that leaked fuel on the runway because the panels were designed to fit only when expanded by heat. They built a plane that grew 6 inches longer in flight. They built a plane that required a separate starter cart with 2 Buick V8 engines just to spin the turbines up to speed. To the Soviet engineers, who prioritized reliability and mass production, the SR-71 was an abomination. It was too complex, too fragile, too demanding. It shouldn't have worked, but it did. The psychological impact on the Soviet military leadership cannot be overstated. For 25 years, they lived with the knowledge that the Americans could fly over their most sensitive installations, take high-resolution photos of their backyard, and be home in time for dinner, and there was absolutely nothing the Red Army could do about it. It created a culture of paranoia. It forced them to hide their best secrets in bunkers, knowing the sky was always watching. It accelerated the collapse of their economy as they desperately tried to close a technological gap that was widening every year. When the Iron Curtain finally fell in 1991, American pilots and Soviet pilots finally met face to face. At air shows and conferences, the old adversaries shared vodka and stories. The Soviet pilots, men who had flown the MiG-25 and MiG-31, asked the Americans the same question over and over again. How did you keep the engines from melting? When the Americans explained the bypass tubes, the moving spikes, and the thermal expansion joints, the Russians were often silent. They understood the physics, but they were baffled by the audacity. They marveled at the fact that a government would approve such a risky, insane design. The SR-71 was retired in 1990, not because the Soviets caught it, but because satellites and budget cuts finally did what 4,000 missiles could not. Today, the remaining Blackbirds sit in museums. They are cold, quiet, and they no longer leak fuel. But if you stand next to the massive inlet of a J-58 engine, you are looking at the artifact that won the Cold War not with a bang, but with a sonic boom. It stands as a reminder of a time when engineers stared at the impossible thermal wall of Mach 3 flight, and instead of turning back, they decided to simply open a door and walk right through it. The Soviets spent decades looking for a weapon to kill the beast, never realizing that the beast was powered by the very thing they were trying to protect: the air itself.